Welcome everyone. Today I will discuss some important problem of definite integral. You know, problems of definite integrals are very interesting. I have already taken 8 classes for competitive exam. Today I will discuss some interesting problems using properties of definite integral. Property, I have already discussed this one, but try to recall. Minus a to plus a fx dx equals to 0 to a fx plus f of minus x dx. So proof is very simple. So look at the proof if you are interested. So this one is minus a to plus a fx dx. So we can write it minus a to 0 fx dx plus 0 to a fx dx. This one. By a property a to b fx dx equals to a to c plus c to b. We can divide the interval into two parts. So minus a to plus a. Minus a to 0, 0. Now 0 to fx dx, it is already in the proof. So keep it unchanged. Put x equals to minus z in the first integral. In the first integral. So dx equals to minus d. Then you know you have to change the limit. If it is 0, then it is 0. If it is minus a, then it is plus a. So this reduces to first one. Look, a. If it is 0, then it is 0. So 0 to a to 0, f of minus z into minus dz plus 0 to a fx. So now, if we change the limit, this is 0 to a, fz dz, and this one unchanged, fx dx. Now, look, we can change the variable z to y. So it is fy dy, and this is f of minus z, f of minus y dy plus 0 to a fx dx. Now, again changing f, this variable y to x. So f of minus x dx. So 0 to a fx. You may change it directly. F of minus z dz equals to 0 to a f of minus x dx. But you may think that there is a substitution x equals to minus z, then this will be x equals to minus z. So if it is x equals to minus z, then it is again fx. So we are using properties of definite integral. Now 0 to a, f of minus x, f of x, same limit. Yes. So this is proof. Sometimes, so in board exam, you have to prove this result. That is why I am giving the proof. In general, proof is not coming. But look, if fx is even function, even, you know what is even function? Even function. So try to recall f of minus x equals to fx. Then it is even. That is which can absorb minus. So cos of x to the power 2n, even power, sec x, they are even function. And what is odd function? Odd function is f of minus x equals to minus fx, minus outwards. So what are the examples? So all trigonometric function except cos x and sec x. So sin x, tan x, odd power, x cube, and so on. Now look, if fx is even, then f of minus x equals to fx. So what we are getting from this result, 0 to a fx plus f of x dx, because f of minus x is fx. So 2 into 0 to a fx dx. So for even function, what is the property? Minus a to plus a fx dx. So 2 come forward, it will be 0 to a. But if fx is odd function, fx is odd, then f of minus x equals to minus fx. Then what will be the result? Look, minus a to plus a fx dx equals to 0 to a fx, and this is f of minus x is minus fx. So f of minus x is minus fx. So this is cancelled out. So we are getting important result. All of you know this. So if fx is even function, so what is our final result? So consequence of this property, so 2 into 0 to a fx dx, if f of minus x equals to fx equals to 0 if f of minus x equals to minus fx. This is odd function and this is even. So function may be even or odd or none also. Suppose sin x plus cos x. So what is f of minus x? Minus sin x. Sin of minus x, cos of minus x. So minus sin x plus cos x. So look, you cannot write it as fx or minus fx. So this is neither even nor odd. So function may be even or odd or none. But there is a most important theorem. Every function can be expressed as a sum of even and odd function. So there is a theorem. Every function can be expressed as a sum of even and odd function. Look, this is remarkable theorem. All of you know it. Try to recall. So we can write fx in this form. So look, fx, 2fx by 2, and this one is cancelled. So you know this is even function and this is odd function. So function may be even or odd or none, but you can express every function as a sum of even or odd function. So fx equals to, for example, sin x plus cos x. So it is neither even nor odd, but you can write sin x as odd function and cos x as even function. So every function can be expressed as a sum of even and odd function. So this will be our working tool. Now, look, minus pi by 2 to plus pi by 2. So, suppose sine to the power 5x. So, sine to the power 5x dx. If, look, result is same but opposite in sign, we always try to use property. So, whether it is even or odd. So, power is odd power. So, you know this is odd function. This is odd function. So, what is the value? Value is 0. So, from property of odd function, you know minus pi by 2 to plus pi by 2 is equals to 0. But now, in board as well as competitive exam, so these results are given in twisted form. So, look, so suppose this problem minus pi by 2 plus pi by 2, this very problem, sine to the power 5x plus x plus x, x cube plus x plus 1 into x. So, if you see, if you consider this as fx, then you see it is neither even nor odd. So, in this case, you have to think if they are opposite in sign. So, if it is neither even nor odd, then you have to think that it can be always expressed as a sum of even and odd function. So, look, you can write it as minus pi by 2 to plus pi by 2. This is odd function. This one is odd function. This one odd function. So, minus pi by 2 to plus pi by 2, 1 dx. This is constant function. So, it is even. So, now this one is 0 and this one is 2 into 0 to pi by 2, 1 dx. This is even function. Fx equals to 1, f of minus x also is. Now, if you integrate it is 0 plus, this is x. So, you are getting answer as pi. So, if it is neither even nor odd, then you always try to express it as a sum of even and odd function. Mind it, if upper limit and lower limit are same but opposite in sign. So, today using this property, I will solve some problems, some interesting problems of board as well as competitive exam. Now we consider two problems using the earlier theory. Now, second one, minus pi by 2 to plus pi by 2, 3x square, 1 plus e to the power minus x dx. Now it is neither even nor odd. You can verify also. So by the previous property, look, they are same but opposite in sign. So first we look whether it is even or odd. If it is neither even nor odd, then we can use the earlier property. So this is 0 to pi by 2 fx plus f of minus x dx. Now 0 to pi by 2, what is fx? 3x square, 1 plus dot x. And what is f of minus x? 3 minus x whole square e to the power minus x. Again. So, proof is already given. Now this one, 0 to pi by 2, 3x square, 1 plus bar x. This is also 3x square, 1 plus 1 by bar x. Now 0 to pi by 2, 3x square common. So 1 by 1 plus e to the power x. E to the power x will be at the numerator and you get this one. Now if you take addition, then it is 1 plus e to the power x, then 1 plus e to the power x. Now this one is cancelled. So x cube 0 to pi by 0 to pi by 2. So we are getting result as pi by 2 whole cube. So we are not getting the result, but look, I think it is minus 2 to plus 2. So correct it, minus 2 to plus 2. So this is 0 to 2. This will be 0 to 2. To get answer, you have to change 0 to 2 and this is 0 to 2. So 0 to 2. So 8 minus 0, so you are getting answer as 8. Answer as 8. So it is neither even nor odd and you cannot indicate it due to presence of x square. So if they are opposite in sign, you always use property of definite integral. Then these are problem not of directly even, not of odd. So use this property and try to solve. So look, most interesting problem. Now the first one. So minus 1 to plus 1. So you can write it. Look, this is x cube. This is mod x. This is even. This is even. And denominator is even function. But it is odd. So it is sum of even and odd function. So you can write it as 0 to minus 1 fx plus f of minus x 0 to 1, 0 to x cube plus mod x plus 1. This is x square 2 into mod x plus 1 plus, what is f of minus x? So minus x cube mod of minus x plus 1 x square 2 into mod of minus x plus 1 x. Now mod of minus x is mod x. Mod of minus x minus 1. So you are getting mod x. So 0 to 1 x cube plus x mod x plus 1. This is x square 2 into mod x plus 1. And this is x square 2 into mod x plus 1. This is minus x cube plus mod x plus 1. Now same LCM you are getting. You are getting same LCM. And x cube will cancel. 2 into mod x plus 2. 2 into mod x plus 2. Now look, you have to remove modulus sign. In between 0 to 1, that is x less than, x greater than 0 and less than 1. So x greater than 0. So in between 0 to 1, that is x is positive. So mod x is positive. So 0 to 1, 2 into mod x is x plus 1. And this is x square plus 2x plus 1. So you are getting 0 to 1 dx by x plus 1. So this is x plus 1 whole square. So 2 log 1 plus x. Here LOG log means also base e. In mathematics, whether it is ln or log, we take base as e unless otherwise given. So we are getting 2 log 2 minus 2 log 1. So 2 log 2 is 1. So 2 log 2 means log 4. Log 4. Look, they are interesting problem. Neither even nor odd, but you can express it as a sum of even and odd function. Now we consider 3 more problems, 3, 4 and 5. So look, problem number 5. So this is minus a to plus a minus a by a plus x. So if no limit is given, we integrate it by rationalizing the numerator. So this is neither even nor odd. So minus a to plus a. First you rationalize it, then we use the forward. So this is a square minus x square. So it is neither even nor odd. So we can write it 0 to a fx, the given function, and f of minus x dx. So 0 to a minus x by a square minus x square. This is fx. So f of minus x is a plus x, a square minus x square. So omitting one step. So minus x whole square. Now same LCM you are getting. So 2a by x cancel, a square minus x square dx. So 2a outside, dx by a square minus x square. Now this one is well known formula, which is standard integration, sine inverse x by 0 to a. So 2a into sine inverse 1 minus sine inverse 0. So 2a into pi by 2 minus 0. So you are getting. So you remember this result. It is general. So what will be the result? If it is minus 2 to plus 2. So 2 minus x by 2 plus x is 2 into pi. A is replaced by 2. So you remember this result for competitive exam. So they are most interesting. You look neither even nor odd, but you can express it as a sum of even and odd ones. Now we consider any one of 3 or 4. So they are exactly same. So these problems are problems of competitive exam and as well as board also. Now look, this is neither even nor odd. So we can write it as 0 to pi. So fx plus f of minus x. So 0 to pi 2x 1 plus sin x. So this is fx 1 plus cos square x. Now what is f of minus x? Replacing x by minus x. So what we are getting? 1 plus cos square x. This is minus 2x and this is 1 minus sin x. So omitting one step. So sin of minus x is minus sin x. Now same LCM you are getting 1 plus cos square x. Same LCM. So 2x plus 2x sin x. And this is minus 2x plus 2x xx. So 2x plus 2x sin x, and this is minus 2x, and this is, so you are getting 0 to pi 4x sin x by 1 plus cos square x. Now 4x sin x by 1 plus cos square x. If x is not present, then if we put cos x equals to z, we can easily integrate it. But here, due to presence of x, you cannot integrate it. So your main aim will be to cancel x using over. So suppose this is I. Then replace x by pi minus x. So 4 into minus x sine of pi minus x by 1 plus cos square pi minus x dx. Now finally you are getting 0 to pi minus 4x sin x by 1 plus cos square x. So this is 1. Now x is replaced by, using this property, 0 to fx dx equals to 0 to a f of a minus x dx. We are using this property. So this is 4 of, this one will be pi minus x, pi minus x. So 4 of pi minus x sin x. So call it 2. So this is our mistake. X to be replaced by pi minus x. So this is 1, this is 2, this is also I. So 1 plus 2 implies 2i equals to 0 to pi. Same LCM, 1 plus cos square x, 1 plus cos square x. This is 4x sin x, 4x sin x, and this is 4 pi sin x, and this is 4x sin x dx. So this is our main aim, to cancel x. So this is our main aim. Now put, so x is cancelled out, cos x equals to 0. So sin x dx equals to minus dz. Then change the limit. Cos 0 is 1, cos pi is minus 1. Now it is very simple. 2i equals to minus 1 to 1 to minus 1. So 4 pi as it is, but is sin x dx minus dz, 1 plus z square. So minus will be plus, 4 pi outside, minus 1 to plus 1, dz by 1 plus z square. So if you change the minus, it will be plus. So 4 pi into, it is even function. So 2 into 0 to 1, dz by 1 plus z square. So it is even function. So 2 into 0 to 1. So 8 pi unchanged. This is tan inverse z 0 to 1. So 8 pi into tan inverse 1 minus tan inverse 0. So 8 pi into pi by 4, because it is 0. So this is 2 pi square. So answer is not 2 pi square, because it is 2i. So I equals to pi square. I equals to pi square. Mind it, someone write answer 2 pi square, but it is 2i. So you should remember, you have to divide throughout by 2 before writing final. final answer. So you are getting y square. So today you have learned how to find value of definite integral for the integrand, for the function which are neither even nor odd, but you can express it as a sum of even and odd function. So thank you for today.